Hello friends, today we are going to learn how to balance a chemical equation. For balancing a chemical equation, friends, we have to follow specific rules of equation balancing method. In this video, we are going to learn one example for which ferric oxide reacts with carbon and gives us iron metal and carbon dioxide. So friends, to balance a chemical equation, first of all, we have to write the skeletal formula if not given. In some cases it is given, but in some cases this type of question is also given. So first of all, ferric oxide. Friends, ferric word is used for Fe, iron, and specifically for friends, iron which has valency plus 3. Ferric is used. So valency of iron is plus 3, valency of oxygen is friends minus 2. Actually, ferrous is Fe2 plus and ferric is Fe3 plus. And that's why this is the valency Fe3 plus. If we cross multiply, we will obtain the compound Fe2O3. So this is Fe2O3 ferric oxide first. Reacts with carbon. Carbon's symbol is just C is to be written. Then it gives us iron metal. So Fe metal is obtained, friends, and the product, another product is carbon dioxide. So this is, friend, our skeletal equation. Remember that an equation which is not balanced is to be said skeletal equation. This is a skeletal equation. Now, friends, method to balance the chemical equation. So it consists some steps. Step number 1, friends, in first step we have to write the skeletal equation and make boxes around the given substances. So first step is to make boxes around all substances in reactants and products. So friends, first one is Fe2O3 plus C gives Fe plus CO2. Now look at here, I am making one box around each one. You can see these 4 boxes are there. Now friends, what is the meaning of this step? So simple meaning of this step is, friends, now we are not able to make any changes inside this box. We can make any change around, outside the box, but inside the box it is not to be allowed. So we can make any number change on left side only in the beginning of the formula of the substance. Okay, friends. So this is the first step in which you don't have to do anything. Just make a proper box around all reactants and products. Now, friends, next step, that is step number 2. In step number 2, friends, we have to check the number of substances, or we can say elements, on left hand side and right hand side. So we have to make a list of substances. So here we write element or substance. This is left hand side and this is, friends, right hand side. So here one small box is to be prepared. You can see the element, first element is Fe. You can see Fe. How many Fe are present? You can see on left side it is 2. So this is 2. On right side you can see it is only 1. So first is this. Second element is oxygen, friends. You can see here 3 oxygen atoms are there. So LHS 3 oxygen. On RHS, friends, it is 2. Now third element, friend, is carbon. And how many carbons? You can see carbon is here left side 1, right side also 1. So this is your step number 2. In step number 2, you just have to make a table in which name of the element is to be written first column, second column, left hand side elements number. You have to check it here in skeletal equation only, and right hand side, friends, this is number of elements you have to mention. You don't have to make any change here up to step number 2. Now, friends, this is the most important step number 3 onwards. We are going to balance elements one by one. So please check it out. First of all, first element is to be balanced, which is available on both sides with other elements. So in short, the alone elements are to be balanced at last. I repeat, alone elements on both sides are to be balanced at last. Right, friends? Because when alone elements are balanced, they are not making any change to other element. But the element which is combined, you can see, for example, is oxygen. You can see oxygen is on both sides together with other elements. So we will balance oxygen first. So balancing of oxygen is to be considered as a first step of balancing. Okay, you can see, first of all, you have to write oxygen here. Then on left hand side, you can see how many oxygens are there? 3. And on friends, right hand side, oxygens are 2. So this is the first step. Without balancing, there are 2 oxygens on right hand side and 3 oxygens on friends left hand side. So there, now what to do? How it is to be balanced? Friends, one number is odd, another number is even. So simple method is to cross multiply them. What to do? Cross multiply them. So this is to be multiplied by 2 and this is to be multiplied by 3, friends. So after balancing, I have to write this is Fe2O3 plus, friends, this is carbon, and then Fe, and then carbon dioxide, CO2. Now what to do? Look at here. LHS is to be multiplied by 2. So oxygen containing compound, this is to be multiplied by 2, right? And this is oxygen containing is to be multiplied by 3. So this is multiplied by 3. So this is the one change we have done. And after that, you can see number of oxygens 2 3s are 6 and number of oxygen 3 2s are 6. So they are equal. So this is one step done of balancing of, friends. Oxygen is done here. Now, friends, in step number 4, we are going to balance other elements. In other elements, you can see Fe, and Fe, friends, is there, and carbon is there. So we can consider anyone, doesn't matter, because both are present on both sides in alone type. So balancing, here you have to write balancing of carbon. So balancing of carbon, before you go for balancing, you have to write the correct formula, which is to be taken from the last step. So 2 Fe2O3 plus this is carbon, and here is Fe alone plus 3 times CO2. Friends, whatever you change here, this change are to be carried forward. For example, this is I multiplied 3, so this 3 is to be carried forward for next steps also. So this is one thing. Now, how many carbons are there? So carbon atom on left hand side, you can see it is only 1, friends, and on right hand side you can see 3 carbons are there, friends. So this this balancing easy. Why? Because this is to be multiplied by 3 and we will obtain the equal number of carbon on both sides. So this is only one multiplication we are going to apply. 2 Fe2O3, still boxes are necessary here. Carbon, this is Fe, friends, and this is 3 times CO2. Now what is the change? The change multiplied by 3. So here I am putting the value 3. So this is multiplied by 3. Done. So this is 3 carbon. You can see here is 3 carbon present. So this is step number 4, in which we balance the element carbon. Now friends, in next step number 5, we have to multiply another element. Which element now we have to take, friends? So you can see the only element is left, and that is what? Iron. So step number 5, friends. In step number 5, we have to write balancing of iron, Fe. So in balancing of Fe, we have to write first what is the available formula, equation. Available equation is, friends, 2 times Fe2O3 plus 3 times carbon gives us, friends, Fe plus 3 times CO2. This is, once again I tell you, friends, this is taken from the last step, right? So now, before that, what is the position? LHS, this is RHS, and this is Fe. You can see, friends, 2 to the 4 Fe atoms are present on LHS. This is 2. This is 2. The number which is mentioned before this substance is applicable to all elements. So here this 2 number is applicable to Fe as well as oxygen, whereas the number mentioned after the element is applicable to only that element. Remember this, it is very important. So this is 2 to the 4, and here is only 1. Once again, friends, it is very easy to balance both sides. How? This is 4, this is 1. So this is to be multiplied by 4. This is the change we are going to make. So friends, finally 2 Fe2O3 and then plus 3 times carbon, friends, gives us, this is Fe plus 3 times, this is CO2, friends. Now listen here, what is the change? This is the change. I am going to multiply by 4. So this is multiplied by 4. This is the change of step number 5. Right, friends? Now we find that all the elements are balanced. Now what to do, friends? In step number 6, friends, we have to remove the boxes. Remove the boxes and write chemical equation. So as step number 1, we made the boxes. In second last step, we have to remove the boxes. Why second last step, friends? Because there is also possibility that more than 5 steps are also possible if more than 3 elements are there. So number of elements are more, number of steps are to be taken more. Here, as we have seen, Fe, O, and C, only 3 elements were there. So 3 different steps we have taken in balancing type. Now, friends, what to do? This is removal of boxes. In removal of boxes, this is 2 Fe2O3 plus 3 times carbon gives 4 Fe plus 3 times CO2. This is called our balanced chemical equation. It is called balanced chemical equation. Now, friends, in step number 6, we also have to do one more thing, that is write the name of element, then LHS and RHS, that number. We have to check that our balancing is proper or not. So for this, friends, we have to write all these elements once again. So first element is Fe. This is 2 to the 4 on LHS. This is RHS. You can see it's 4. Second element is oxygen, friends. 3 to the 6 oxygens present on left side, and this is 3 to the 6 on right side. Then, friends, carbon, you can see this is 3. Here is also, you can see 3. Right, friends? This is step number 5, 6, and last step is step number 7, in which, friends, we have to write the physical state of matter. So write the states of matter. Right? So this is 2 Fe2O3, friends, plus 3 times carbon plus 4 Fe plus 3 CO2. Friends, before you write the correct state of matter, you have to check few things only. Which few things? That is very common sense question. Fe2O3, friends, available in solid form from the crust of earth. So this is available in solid form at room temperature. Carbon, coke, is also available in solid form at room temperature. This is the common state of matter of element. Same iron. Iron metal is available in solid form at room temperature. That's why this is also solid. Carbon dioxide, friends, as you know, is in gaseous form at room temperature. That's why this is, I have written, the CO2 gas. So now all 7 steps are there. Steps in this balancing may be vary, may be change as per number of elements change. But friends, some steps, for example, step number 1, in which we are writing the box making step. In second step, friends, we are making the LHS and RHS. These steps are common for all balancing. Then after third, fourth, and fifth, as per required number of elements, we have to make balancing of each element in one step. And finally, we have to remove the boxes, and as we find all the elements are balanced. And finally, we have to check also, cross-check also number of elements on both sides. After that, you can see before and after boxes are changed different. Okay, friends. And finally, state of matter is to be written. Okay, friends. I think you got it. Thank you.